Pure Math 030. This is an exercise on radian measure. That is the little rad key that's on your calculator that we've been avoiding until now. And it becomes a real big part of this course, this unit, and in fact any trig that you take in the future will probably emphasize radian measure over degree measurement. But that's what it is. Radian measure is an alternate form of angle measurement. So instead of measuring an angle in degrees, you now measure it in rads. So I'm going to start off with where it all comes from and how simple it is to actually start with this. If you take a look at an ordinary circle with a radius of r and an interior angle of theta, let's say. Now this one is not superimposed over an xy coordinate grid, rather it's just a circle in space, any circle. And if you take a look at the section of the circle that's cut off, if you like, by that angle of theta, that's A, and it's called the arc length, and technically it's subtended by theta. Subtended just means opposite to the angle. But every interior angle that you have in that circle is going to have its own sort of arc length outside of it that it cuts off. Call that A. And if we want to calculate the measure of that angle, that interior angle, in rads, so the unit for radian measure is rads, we would take that arc length A and divide by the radius. Simple as that. And on your formula sheet, it is provided for you, although they do not write it in that form. Rather, it gets written like this: A is equal to r theta, sometimes called the arc length formula. And if you know when to use it, very simple. What's on your mind probably is, how do we use this for any sort of question? Or where will it come up? Well, here's kind of a simple example. For this circle, we want to find the measure of theta in rads, given that we have a radius of 8 centimeters and an arc length of 8.5 centimeters. So you just go to the formula. 8.5 divided by 8.0, and if you round that to the nearest tenth, you'll get 1.1 rad. Now obviously for most people, or you can imagine, I guess, that this is not a very convenient way to deal with it. It's easier to visualize a degree. Like if you were told that this angle was about 60 degrees, most of you could imagine how big it was. And with rads, it's not so simple yet, but you do tend to get good at it with a lot of practice. So that leads us to the idea, the relationship between degrees and rads, and how we can convert from one to the other so that you can develop a good sense of what a rad is. And I strongly advise you to work in radian measure as much as you can and avoid, even though we do learn these conversion methods for it, that's mostly so that you can, for special cases and also to develop a sense of what a rad is. Mostly you want to work with rads and not go back to degrees unless you have to. So if you were to consider a circle with a radius of r, just like we were looking at before, I'm going to take a full rotation of this circle. As you can see that with the diagram, we get this arc length all the way around the circle. So in other words, I've taken a full sweep, 360 degrees. Now the arc length of a full rotation would be the circumference of the circle, the distance around it. And in case you've forgotten, the formula for circumference of the circle is 2 pi r. So now I'm going to go right into the formula that we've got, the arc length formula, where theta is isolated. And since theta in rads is equal to A over r, we can therefore say that theta in rads will be equal to 2 pi r divided by r, the distance around for that full rotation. And that r will cancel, so we would get that one full rotation of a circle is equal to 2 pi rads. And we can then say, since we know that one full rotation is 360 degrees, that these two are equivalent. You could measure an angle of 360 degrees and call it 360 degrees, or you could call it 2 pi rads. If you divided both of those by 2, you could get a simpler conversion ratio, which is that 180 degrees is equal to 1 pi, or pi rads. I'll also mention that many times if you are dealing with radian measure, and you've got a pi in it, such as we do right there, they don't bother putting the rads because it's understood to be in radian measure. And so you'll see that a lot of times the unit gets dropped, but only if the pi is there to indicate that that's what we're working with. Now I'm going to take a look at a circle. Now this time I've imposed some grid lines on it, but that's just so we can measure some angles more easily. And we do know this: 360 degrees is 2 pi rads, 180 degrees is pi rads. And without any formulas, just using simple reasoning power, I'm going to find out equivalent measures between degrees and angles, degrees and rads, throughout this circle. If 180 degrees is 1 pi, it would stand to reason that 90 degrees is 1/2 pi, or pi over 2. Just divide both by 2. So from here on in, anytime you see an angle of 90 degrees, you want to be training yourself to recognize that as pi over 2 rads. If you step down to the bottom, halfway between 180 and 360 is 270. And halfway between 1 pi and 2 pi is 1/2 pi. 1/2 pi would be 3 over 2 pi. Let's fill in a few more. If you cut that 90 degrees in two, 90 divided by 2 is 45, and then pi over 2 divided by 2 is pi over 4. So we get a very important conversion ratio. 45 degrees is equivalent to pi over 4 rads. Now you could also have got that by going 180 divided by 4, and then pi divided by 4. So if you know that 180 degrees equivalent to pi, you can break it down into most of these special type angles. I'm now going to take that 45 degrees and go around the circle. I'm going to go into quadrant 2. And if we had a 45 degree reference angle in quadrant 2, that's 135 degrees. And that would mean that it's equal to 3 pi over 4 rads. You could find this by taking that 45 degrees and multiplying by 3, and therefore pi over 4 times 3 is 3 pi over 4. But in any way that you do it, 135 degrees is equivalent to 3 pi over 4 rads. If we take a 45 degree angle in quadrant 3, 180 plus 45 is 225. And that would be equal to 5 pi over 4. So another way of looking at it is 45 degrees times 5 is 225. So pi over 4 times 5 is 5 pi over 4. It's all based on that 45 degree angle in quadrant 1. And then in quadrant 4, if you have a reference angle of 45, that would be 315 degrees for a rotation angle. And then that would give you 7 pi over 4. So pi over 4 times 7. Then, if you go back to this circle again, taking off the 45s, I've got lines in there representing 30 degrees and 60 degree angles in each of the 4 quadrants. And let's work our way through these. In quadrant 1, a 60 degree angle would be equal to pi over 3. So I got that simply by going 180 degrees divided by 3 is 60. So therefore, pi divided by 3 would be pi over 3 rads, just simple ratios. But it's important to remember 60 degrees is equivalent to pi over 3 rads. You'll see that one all the time. Then a 60 degree reference angle in quadrant 2 is 120 degrees. And that would be 2 pi over 3. How did I get that? Well, starting with 60 degrees is equal to pi over 3. 60 times 2 is 120. So pi over 3 times 2 is 2 pi over 3. And now I'm going to go into quadrant 3. A 60 degree reference angle in quadrant 3 would be 240 degrees. So 60 times 4 is 240. So pi over 3 times 4 is 4 pi over 3. And that's the equivalent angle in quadrant 3. A 60-degree reference angle in quadrant 4 would be 300 degrees. 60 degrees times 5 is 300. Pi over 3 times 5 is 5 pi over 3. So that's equivalent there. Finally, let's go after 30 degrees. Now 30 degrees is 1/6 of 180. So therefore, the radian measure has to be pi divided by 6. And if we go into quadrant 2, with a 30-degree reference angle, 30 times 5 is 150. So pi over 6 times 5 is 5 pi over 6. So 150 degrees is equivalent to 5 pi over 6. Keep going. In quadrant 3, a 30-degree reference angle would be 210. And therefore 30 times 7 is 210. Pi over 6 times 7, 7 pi over 6. And finally, in quadrant 4, a 30-degree reference angle is 330 degrees. And that's multiplying the small angle of 30 by a factor of 11. So pi over 6 times 11 is 11 pi over 6. Now some of you are looking at this and thinking, no problem, I see the patterns really clearly, I'm okay with this. And others are thinking, whoa, there is a formula that we use to work them out. So you don't have to memorize these, but it's highly advisable that you do at least the first quadrant ones. And plus you work with them so often, you just tend to get familiar with them. But take the time to understand the patterns and do not rely on the formulas overly much. And also quadrant 1, you can see 60 degrees is pi over 3, 30 degrees is pi over 6. A few screens ago we had 45 degrees is pi over 4. So if you keep all those ones in mind, you're okay. Know the quadrant 1, everything flows out of that. Now the conversion formulas I just referred to, if you have to convert from rads to degrees, we simply take the number of rads we've got and we multiply it by 180 over pi, because 180 to pi is the conversion factor. And by doing this, that will cancel out the pi and introduce the degree symbol. And then degrees to rads would be more like this. Very similar thing. We take the degrees that we're given and we multiply by pi over 180 degrees. This will cancel out the degree symbol, introduce the pi. So let's do a few examples. Convert these into an equivalent form, either rads or degrees. So 195 degrees, okay, we're going to convert this into radian measure. You'll notice that this is not one of the angles covered on the circle that I drew. That circle, I only looked at the 30, the 45, and the 60 degree reference angles. Those ones most people memorize. This one is not there, so you probably won't have it memorized. So you use the formula. 195 degrees times pi over 180. And now this is just fraction reduction. The degree symbols will cancel. And then 195 over 180, if you divide top and bottom by 15, you'll get 13 pi over 12 rads. I did put the rads in for this one. And that's an exact value measurement. It's not decimalized. By keeping the pi there, we know we've got an exact value. Let's take a look at another one. Here we have 3 pi over 8 rads, and this one we want to convert to degrees. So I multiply by 180 on top over pi. I want to cancel the pi's, so I know the pi goes on the bottom, and introduce the degree symbol. Pi's go away. They cancel, so it's really 3 times 180 divided by 8, which is 67.5 degrees. And again, this is not one that we are expected to memorize. Only the ones with denominators of 2, 3, 4, and 6 do people get down without having to do any sort of calculation. Number 3, an interesting one, 1.0 rads, and we want to convert this to the nearest tenth of a degree. First off, this is not an exact value because it doesn't have the pi symbol there, and that's why you're being asked to decimalize it. Second off, most people want to know what is 1 rad equal to. So here we can get an answer. And I do the same thing. To convert to degrees, I multiply by 180 over pi. The only difference is that because I'm decimalizing it, I go 1 times 180 is 180, and then I divide by pi on my calculator. So 180 divided by pi, key it right in, and then if you round to the nearest tenth, you'll get 57.3. And that's correct. 1 rad is about equal to 57.3 degrees. So that's the lesson. Very important to get comfortable with these. And the circle that we looked at, which is really the start of what they call the unit circle, has got all the major conversions that you work with probably 70% of the time. The 30s, the 40s, the 45s, 60s, and then in all 4 quadrants. So a very important exercise to get comfortable with. Trigonometry isn't really that hard of a unit, but there's a lot of little things that build up. It's like learning a language, and you have to get command over the radian measure, getting comfortable with the conversions, doing enough so that you don't have to fumble your way through it. Thank you for your time.